Thank you for taking the time to talk to us about how to develop deep learning EAs on top of star traders, VPS systems. Very exciting. Now, that's interesting because you're developing EAs using deep learning on top of our VPS systems. And we're seeing deep learning being deployed all over the place, everywhere, in retail, in shampoo development, in everything, in medicine. What does that mean for financial stability in the world? Well, just before we go into answering that question, Star Trader, of course, is a company that you recognize as being a company that has won a number of awards. I'm not going to go through them right now. And the purpose of this presentation instead is to talk about how deep learning will affect financial stability. How is it relevant? Well, deep learning, first of all, is transformative. It will change, it is changing, it has changed the world. Go back 12 months, we couldn't have had a discussion about ChatGPT and Bing AI and OpenAI and so forth. Whereas now everyone understands that these things are totally mainstream. Go forward 12 months and it will go far beyond that. So deep learning is transformative for humanity. From a financial standpoint, deep learning has two primary effects because it's used to set pricing and it's used to allocate capital and risk. So that's a hell of a summary, but it's a valid one. Set pricing and allocate capital and risk. If deep learning is used to do those things, then deep learning has a grip on financial stability, and it does. So what's going on? Well, deep learning touches us now. In the world of finance, we see AI-based hedge funds and high-frequency traders use deep learning. They've been doing it for some time. And asset management platforms worldwide are using deep learning, as I said, allocate capital, allocate risk. They do it in order to predict how we behave. They do it in order to predict buy, sell, and pricing and so forth. They do it for securities lending and for capital allocation. Deep learning is everywhere in finance right now. How does it work? Well, deep learning is kind of simple because you have some inputs and you have some outputs. Between these inputs and these outputs, you have groups of algorithms and functions and nodes, if you wish. And these groups all have individual parameters for them. Each one functions in a different way. The input comes in, it goes to a number of different places. The same input goes to different places, is used, fed in a network. The network can reconfigure itself and out come a number of results, a number of outputs. It's hyperdimensional. What does that mean? Well, there are so many different functions here that you don't really know how many parameters you even have because these functions can replicate themselves. So in normal space, we have, in order to work out where we are, we have X, Y, Z. Maybe we have the smell, that's 4 dimensions, the color, that's 5 dimensions, temperature, that's 6 dimensions, and so forth. Whereas in this instance, we can have millions of parameters that set the relationship between the input and the output, and that's what's called hyperdimensional. And within that world, if you're trying to work out when something peaks or when something troughs, it's difficult to know if that's the best bottom or the best top, because there are so many bottoms and tops in this landscape. So hyperdimensionality is a mathematical challenge, to put it mildly. Additionally, each of these functions or each of these nodes inside this big network, they don't just sort of gently affect the result. They can go exponential, they can behave in many different ways. So it's not linear, so it's not difficult to, it's not easy to go back and try to work out what happened. the whole input space, the whole number of parameters is too big, so you can't look at the input and the output and then work out what goes in the box, because it's too complex. You can't sort of retrofit and try to work out why something happened. You just have to go, okay, so that's how it worked. And these systems are self-learning, so you run the model once, it learns, you run it again, you're exactly the same model, and you'll get a different answer because the model learned from itself from one time to the next. So there's a dynamic complexity to these models as well, and they have a huge hunger for data. They use incredible amounts of data. So that's how complicated these animals are. So these things that define the way our world functions in 2024 and 2025 are things that are too complex for us to understand. And indeed, if these were understandable relationships, then we wouldn't need deep learning. In that case, we could just use if-then statements in order to run what we do. So what's the environmental world in which deep learning sits? Well, what's the challenge? What are the big risks? I think there are two big risks with deep learning for financial stability in the world. The first one is something called herding, and the other one is interconnected. Herding and interconnecting. So we humans, we tend to behave in big groups. So if all my friends say something, then I'll say the same. If all my friends get married, I'll get married. If all my friends get divorced, oh, that's a terrible thought. So, but that's the way that we humans do behave. And you see the same thing in financial services. So in the 1970s, we had the Latin American debt crisis, 1980s US savings and loans, the 2009 year 2000 exuberant dot-com crisis where money was cheap and everything could just roll. That had its madness in it. The 2007-2008 quantum subprime disasters, all of those were down to herding. We kind of behaved in the same way. Partly herding and partly the interconnectedness of all of these things. 1929 Great Depression, the fact that the banks had problems then had interconnected effects on everyone else. The Asian financial crisis had an effect on the rest of the world. The 2012 Greek financial almost meltdown had an effect on the full Eurozone. So those two main issues, herding and the interconnectedness, are the ones to look out for in terms of the risks associated with deep learning in the financial markets in our world. So let's dig into those risks a little bit deeper for a moment. So what are the risks? I came up with 5 here, or we came up with 5, I should say, because this was together with the technical team here at Star Trader. Number 1, data. So concentrated aggregators using the same data means that we have a risk where we have to have herd mentalities again. There are some fashionable short data series with very little history behind them that will get high prominence, and that has a risk. We've seen that ourselves. You go to TikTok, you go to Instagram, there's something new fashionable and oh, everyone goes crazy. The same happens in the world of data. So either concentrated aggregators or fashionable short data series, those are 2 data risks. The next thing is model design. Now, if we all use the same models, then that's a risk, because if we don't have diversity, then if someone gets it wrong, then we all get it wrong. That sounds really unlikely until we look back to the 2008 financial crisis, where Standard & Poor's and Moody's and Fitch ultimately used the same faulty assumptions, the same faulty data, and the same faulty methods of analyzing these things. So they were all wrong. And based on that, there was underwriting of collateral debt obligation CDOs at enormous levels, and bang, everything just blew up. Why? Well, there were quite few people who thought seriously about these things, and they all communicated with each other, and then they all drew the same conclusions, and they were all wrong. So that's the way that rolls. Today, with these new models coming through, deep learning models, there are very few engineers who really understand these things, and respectfully, just like S&P, Moody's and Fitch, they have similar mindsets. So there are risks with model designs. There are also risks caused by regulation. So there are regulatory risks, and that's quite humoristic in a way, because regulations cause risk to financial stability because there are rules and regulations coming through that people will embed inside their models, and that will standardize uniformity, and that will in itself cause herd mentality, which is dangerous. So regulators will need to think twice about the way that they write their rules, and people who implement those regulations will need to think twice about how they regulate them, implement them to maintain diversity. Furthermore, there's algorithmic coordination, because if you have a model and I have a model, then the way it works in deep learning is that your model and my model will be connected either directly or via some shared data somewhere on the internet. So our models will collude whether we like it or not. Collusion is unavoidable because models feed each other. So that again brings us to a lack of diversity. And the last lack of diversity risk that I'd like to pull into this is on the user interface level, because even though the models might be quite diverse underneath, if we all use large language models like ChatGPT and Bard and the Microsoft tools, then these user interface summarize the underlying things. And if we then draw a conclusion based on the same summary methods, then again, the risk goes up, the diversity goes down. We need to plan. So one thing is going ahead at full speed, but at the same time, we need to plan for life after the crash. Let's assume that the whole thing blows. We need to work out how we can ascertain what caused this. I mean, yes, we must accelerate. We have no choice. But while we are accelerating, we know that the risks are increasing at the same time. And at some point in time, pyramid scheme, boom, it's going to pop. It might not pop for 10, 20, 30 years. It will pop very probably at some point in time in the future. So planning for how we will discover what happened makes sense. So we need to work out how we're going to discover why things went wrong. At the moment, we don't have the tools for it. We can use deep learning in order to understand how deep learning caused this failure. That's quite ironic. But planning for life after the crash does make sense. In the meantime, let's accelerate. Why? Because there's only one way forward. We have no choice. Everyone else is increasing efficiency, increasing productivity, improving performance by using deep learning. You and I need to do the same. We have no choice. Deep learning helps with our decision making. It helps with innovation. It's powerful. But while we go full speed, we need to have eyes open. Yes, we can download models from huggingface.co. They have 130,000 models ready for download right now. They have 27,000 data sets ready for download. Yes, we can download models from OpenAI's GPTs. Yes, we can use Microsoft Azure AI API. We can all share those models. We can talk to each other. We can do all of those things. We should do those things. But let's just remember, if we take a ready-to-go model from Hugging Face, by way of example, then we need a data set. Okay, so we can download a data set from Hugging Face. Good. And that data set will need its weighting. Some data is more important than others, so we have data weighting on top of that. We have loss weighting on top of that. Some data is relevant in one context, but not relevant in a different context. So we have attention mechanisms we need to think about. The model itself probably should be trained step by step. So you start with some really simple cases and then you build it into being more and more complex. So I think that's called curriculum learning. So that needs to be done. And data augmentation makes sense in order to train models. So you give the same input multiple times. I repeat myself when under stress. I repeat myself when under stress. Data augmentation, I think, is important as well. All of these things make things better. Luckily, we can download all of those from Hugging Face. So we can get the model, we can get the data, we can get all of the weighting parameters downloaded from Hugging Face and just run. Hold on, I think I just said that what we can do is we can do exactly the same thing as someone else. Well, that's one of the things that causes risk. And yes, that is one of the things that causes risk. You can see that we're thinking about these things actively within Star Trader. The reason we do that is because you are the center of our universe, and we need to understand what risks live in the world in which you are. We give you the power of choice. We want to understand the tools. We want to give you a global team living in all the cities where you live. There's a complexity to all our products. People choose us because of the personalized environments that we provide, because of the dedicated account managers. In terms of which products, we have such a big richness of products around us that talk to your personal account manager, think about what you want to do together, and try to pick the right tools for you to achieve the goals that you have. It's different for every single person. We have a customized partner portal, which I warmly recommend that you check out. If you're setting up a new business or if you're building your business, then we have partner sponsorship programs and so forth to go with that. And let's do business, let's have some fun. And in the meantime, let's be ready, because there might be a meltdown that has nothing to do with us, but it's part of our world. Thank you for taking the time.